Okay, so the good news is we're almost there. We're just going to do some more work with sketching inequalities. Okay, so if you were confident with everything from GCSE, really the discriminant is the big new thing for you. If we need to sort of do a little bit more work on this, hopefully this is a bit of a recap for you. So, question is, solve this quadratic here is greater than 0. So how do we go about solving quadratics and solving inequalities with quadratics? Well, every time we get 0 on the other side, don't we? Okay, that's the format that we're used to dealing with. If possible, factorizing would be a good first step. So if we factorize, let's have a look. What do we get? We get... Right. Let's try just revealing if it will let me. No. So this one here, sorry about that. So 5 and minus 3, and we know that that means that our roots are minus 5 and positive 3. And then we do a sketch based on the coefficient of x squared. So it's positive, so a positive shape. Now, the inequality part, that's our reasoning part. So we've sketched it. Remember I said sketching is non-optional. Yeah, you need to sketch. Greater than 0, go to the graph. Well, here is greater than 0, and here is greater than 0. But we're solving with x, so it's not enough to just say that. What we're saying is, with this graph, what x values make it so that the graph is above 0? Well, it's the x values off to the right-hand side and off to the left-hand side from there. Set notation would be a good way to do it. So the rule for x is that x needs to be less than, not less than or equal to, less than. Okay, sometimes it could be or equal to. You must get the inequalities exactly right. So less than minus 5 union x is greater than 3. Okay, that's what we're looking for. So the steps are, make sure if it doesn't have it already, that there's a 0 on the other side, so the quadratic's all on one side. Attempt to factorize. For these questions in the book, I think it's pretty much always factorization. We sketch it, think about smiley face or frown is the classic, and then reason. Don't forget, it's about x, so the answer needs to involve x as well. So let's just reveal this one here. This one, it's the same quadratic, but notice it says, where is the graph less than or equal to 0? So factorize the same, sketch the same, but the region that I'm interested in, well, where is the graph less than 0? It means, the y part. Where is it less than 0? Or below the x-axis, and that happens here. It also includes the zeros based on the inequality. So for this one, you could write your inequality like that, or you could write it with an intersection sign if you prefer. So it's greater than or equal to minus 5, but it also must be less than or equal to 3. Okay, so same technique, but very different answer. That's why you need to sketch it and think carefully about what you're doing. A couple more examples, so let's just do a couple quickly. Solve this one. Step 1: get all the numbers on one side. So x squared plus 5x plus 4 is greater than or equal to 0. Attempt to factorize. So let's give that a go. So 4 and 1, isn't it? So 4, 1. So that means I'm talking about minus 1, and I'm talking about minus 4. It's x squared, so it's shaped like that. It's quite a bad sketch, actually. Let's do something like this. And what's the question? Where is it greater than or equal to 0? Well, it's greater than here. So I'm going to be talking about less than minus 4. And don't forget that all equals. So less than or equal to minus 4, or greater than or equal to minus 1. That's my rule for x. Okay, so if you do that, you get a bunch of marks. Pause now then, have a go at your term, and we'll reveal the challenge as well. Okay, so your turn, did you spot that this was a difference of 2 squares? Yeah, that's coming back from GCSE. So 3 and minus 3, and we were looking for strictly less than 0. For this one here, the root was a bit more complicated. Just solve 2x minus 7 equals 0. Move the 7 over, divide by the 2, 3.5, or 7 over 2. Okay, but the technique's exactly the same. Let's look at some variations, so some that are a little bit different. So find the set of values for which 6 times the reciprocal of x is greater than 2. So this really is just an extra point here. Why can we not just multiply things by x? So what do you have to be careful of when you have inequalities? You have to be careful of negative signs, don't you? If you multiply by a negative, you have to reverse the sign. So why can't we just multiply both sides by x? Well, x could be a positive number or a negative number, it's a variable. So we have a little bit of an issue here. So one interesting case, what we might do is instead of multiplying both sides by x, we might multiply by x squared, because x squared is always positive, isn't it? So what would you get then? Well, you would get 6x. Where is that greater than 2x squared? Okay, and that would actually turn into a quadratic like we've just been dealing with. This is very much sort of something that is more related to the further maths, but interestingly, it is in the textbook and it is in the slides. Okay, so a quirky situation. Okay, very quickly, have a go at those questions there on the board then. I'm going to pause the video and then I'm going to, I'd like you to pause the video and then I'm going to reveal the answers. Okay, so here are our answers. You could use different techniques. Question 3, notice solving, because it's sort of in completed square format, rooting both sides. Okay, the positive and negative root of both sides, then minus 3. That would be a quicker way to get those roots. And you may have a quadratic that is not starting with 1x squared. And that takes you to exercise 3D and E. Final part we're going to look at So just the very, very final part is more about inequalities and graphs. So we've dealt with a fair bit of this already, like this example here at the top. One other thing that we could do is perhaps we could talk about a quadratic and straight line. Okay, so let's have a look at this example here. Something like that. So we've got our quadratic and our straight line. Shows them on the same axes. There's no new information there. Find the coordinates of P1 and P2. So how do I find coordinates of intersection graphically? Well, that's the same as solving algebraically. So if you use substitution, if you say, well, let's do the substitution, because this one confuses people sometimes. If there's a y there and a y there, what you can do is you can just sort of set them back to back. So if I say y equals 12 plus 4x, and I write x squared equals y, can you see they're sort of back to back, they're the same thing? It's just the same as doing that, okay, if you want a shortcut. So x squared equals 12 plus 4x. This is still solving simultaneously what I've done, that's a substitution, okay? I get this one here, and this will give me my points of intersection P1 and P2. In fact, let's reveal those. So minus 2, 4, and 6, 36 should match the graph. If you get numbers that are in different quadrants, the positives and negatives are all wrong, that suggests that something you're working out is wrong. So that's something you should check as you're going along. Hence, write down the solution to the equation 12 plus 4x is greater than x squared. Okay? So 12 plus 4x is the line. X squared is the curve. So what this is really saying is, where is the value of the line above the value of the curve? Well, A helps you answer that. The line is above the curve between here and here. And you know those values are 2 and 6. So the line is above the curve between, minus 2, should be minus 2, between minus 2 and 6. And that's the answer. So let's just do it on there. So it's between minus 2 and 6. Okay, and I think, in the interest of time, I think we will leave it there. So solving simultaneously will find the intersects. Remember to sketch things and think about those inequalities carefully. And that will help you out with chapter 3. I hope that helped.